Hi, hello, welcome back to Dr. Zahir Math. In today's video, we are going to cover key foundational concepts of linear systems and matrix methods in Module 3 of MA 203 Differential Equation course. MA 203 Differential Equation course. Right. Before going to this one, let me tell you what are the things I'm going to cover in this video. Number one, first I'm going to cover write a linear differential equations, or you can say write a linear system, okay, as a matrix. So it means some system of equations will be given and you're going to write in the matrix model. And the second type of problems I'm going to do, converting a matrix or matrix, converting a matrix, right, into a linear system. Converting a matrix into what? Linear system. The third one I'm going to do it. The questions are expressing the differential equation as a first order system of equations, as a first order system, right, using matrix notation, okay. So this is the third one I'm going to do it. And the fourth one is verify, right, x of t is a solution for a linear system of equation of a linear system, whatever it is, of a linear system. The last section which I'm going to discuss is find the general solution. What I'm going to do it, find the general solution, right, of a system of differential equations, DE means differential equation, okay, right. So let me tell you what are the things I'm going to do it in this video, which is the last section. Already I posted total videos, 9 videos in module 3, and this is the 10th video. That's why I'm calling as part 10 video. So module 3 10, part 10, the last section of module 3. So what are the things I'm going to do? First thing, a linear system will be given and you will be writing in terms of matrices, okay. Linear system will be given, you will be writing in terms of what? Matrices. Next, a matrix will be given and you will be writing linear system. Matrix will be given and you will be writing what? Linear system. The third thing is differential equation will be given and you will be writing in terms of first order system, and finally you write the answer in the matrix notation, right. The fourth thing which I'm going to do is verify x of t is a solution for the linear system of equation. That means something will be given, x is equal to, y is equal to, and a differential equation is given. You need to check this is a solution for this differential equation or not, right. Next, the last thing is we are going to do is find the general solution of system of differential equation. This is the last part we are covering, okay, right. Find the general solution of system of differential equation. So these are the things we are going to do in this video, right. So before going to this video, please let me have a quick update. I already done the videos on eigenvalues and eigenvectors and diagonalization. So please, this is a must watch video before moving into this topic. So just have a look and then come back to this video, right. And for every video, in the comment section and in the description box, I'm putting the Google Drive link. So where whatever things I'm doing as a video, it will be as a PDF model, okay. So you can click it and you can see the handwritten material, right. And subscribe for more step-by-step lessons in differential equations, okay. Let us start the first question. First thing, 8.1, write the given linear system of equations in a matrix form, okay, right. So what it is given, x dx by dt equals, you are going to write linear system to matrix form. So a linear system is given and you are going to write in the matrix. What do you mean by linear system? This is a linear system of equations. You are going to write this in the matrix form, okay, right. So this is the first question. So what you need to do, the solution, okay. The left hand side, you are going to open a matrix, right. So here dx by dt is there and here dy by dt is there. Just write equal and then after that you write here, this is the 2 by 2 matrix. So this is 3, right. And then you write 5 minus 5, then you write 4, then you write 8. This x and y, you are going to make a column vector. So you're going to make a column row vector x, y. That's a column matrix. Sorry, not a vector, column matrix. Right. So how it will come? First row, first column. Come on, check it out. 3x plus minus 5y. 4x plus 8y. So first row, first column, right? When you are multiplying. Second row, second column. In this way, we used to do the multiplication. So therefore, this system of equation we can write in a matrix model. Matrix. Okay. Usually I say matrix, but you can also say matrix. Matrix is the correct pronunciation. Right, first row and then first column. Right, clear everybody? Right, let me go here and then first row, first column. Right, let's go to the next question. Write the given system in matrix form. Again, let's go to the solution. Right, so here it is dx divided by dt and dy divided by dt as a column matrix. This equals, and here you're going to open a matrix. This is a 2 by 2 matrix and two variables are there. First variable is 4 and the second variable is minus 7. First variable is 5 and the y is missing. So we are going to write 0 and the column matrix as x and y. Check it out. First row, first column, and first row, second row, first column. Okay, second row, first column. 4x, yes, minus 7y, yes, 5x, yes, plus 0y. Yes, we got it. Okay, let's go to the next one. Write the given linear system in matrix form. So you're going to write linear system in matrix form, right? So when you look here, it is 3 variables are there. X, Y, Z, right? X, Y, Z, everything is there. So we are going to do this one. Okay, right. X, Y is there. So let me start the solution, right? It's a 3 by 3 matrix, keep in your mind. So I'll start the matrix x dx divided by dt. You can also write x dash of t, dy by dt and dz divided by dt, which is equal to matrix, right? Look here, x variable, y variable, z variable. So here z is missing. So this is called minus 3x and this is plus 4 and this is 0. X, y, z variable, keep in your mind. The next 5 and then y is missing. There is a y missing. Can you see that? And the z is 9. And here x is missing. So 0 and y is 1 and z is 6. Okay. After that, there are some extra fittings. Can you see that? In the class I told you, these are all extra fittings. Always keep in your mind. So in general, we call it as some technical name is there, but you just remember this is just like extra fittings. So I'm going to put plus and write it as an extra fitting. Okay. Right. What is that? E power minus sine t sine 2t. Suppose something is missing here, you put 0. But it's not missing. E power minus t cosine 2t. And the last will be what? Minus e power minus t. Okay. Right. Now make sure whether our answer is correct or not. Dx by dt equals, what did I say? I said first row, first column. So this is first row. And I'm sorry, I'm missing x, y, z. Sorry. So there is a plus here and miss the column matrix x, y, z. Right. Make sure your first equations you are getting or not. Minus 3x plus 4y plus 0z. Check it out. Minus 3x plus 4y plus 0z. And then plus e power minus t sine 2t. Yes, first equation is okay. Second equation. 5x, first second row, first column. 5x, 0y, 9z. 5x, 0y, 9z. And then plus this one, 4 e power minus t cosine t. Next third, 0x 1y 6z, 0x 1y 6z, and then plus this last one, minus e power minus t. So this is called what? Linear system. Okay, right. And this is called what? Matrix model or matrix form. Okay, clear everybody? So now I did 3 questions based on which idea? The first idea, what is that? Given linear system and we are converting into matrix form. Okay, let's go to the next one. Now matrix is given and you are going to write the linear system. Now what is given? Matrix is given and the linear system you are going to write it. Okay, yes. So let's start this question. Okay, right. So now you see here x dash, you keep in your mind x dash is nothing but your dx by dt, or you can write, if it is a 2 dimension, you are going to write x dx by dt, sorry, 1 minute, dx by dt, okay, and dy by dt. Keep in your mind, okay, right. If it is a 3-dimension, x dash will be dx by dt, dy by dt, dz by dt. Keep in your mind, right. Let's go to x dash. So let me go to the solution. There are two questions are there, right. So this is dx by dt and dy by dt, okay. So this is your x dash. This is equal to 4, 2, minus 1, 3, and your capital X is equal to, either you can write xy or you can write x1, x2, no problem. So let me write as xy as a column matrix, and then plus, I just multiply this one, which is e power t, multiply this one, which is minus e power t. This is called extra fitting. This is called what? Extra fittings, right? So let me write the answers now, right? So let us make answers, okay? We'll check it out now. So x dash we will write as dx by dt, dy by dt. And this is a matrix, this is a matrix we wrote it. X we wrote it as a column matrix as xy. Then the extra fitting we wrote it as what? E power t and e power minus t. Sorry, minus e power t. Now what is the question? You are going to write this matrix as what? Linear system you are going to write it. Let us start now. So dx by dt is equal to, right, first row first column I said, which is 4x plus 2y, right, and then first element of extra fitting, which is e power t. Then dy by dt is equal to, right, second row first column, so minus x plus 3y is plus minus e power t. So this one, this minus e power t. So this is called what? Linear system of equation, right? And this is called what? Matrix. Let's go to the second question. The second question, if you see here, there is an extra fitting here, and here also there is an extra fitting here. There are two extra fittings are there. So let's go to the solution, right? It is also 2 by 2 matrix. So we will write x dash as what? Dx by dt and dy by dt. This is equal to matrix 3, minus 2, 5, 4. And I told you capital X is what? It's a column matrix, right? X and Y. Plus the extra fitting is minus 2 sin t, okay, and 3 sin t. How did I get this one? I just multiply here and multiply here, okay, right? First row, first column, second row, first column, and then plus 0, 2, right? So we are going to write this as an equation model. How we are going to write this in equation model, which is dx divided by dt is equal to first row first column, which is 3x minus 2y, and then plus too many extra fitting. This is also extra fitting and this is also extra fitting, right? Yes. Okay, what is that? Yes. So this is minus 2 sin t plus 0. Of course, teacher, I need to write 0. Yes, no problem, right? And dy by dt is equal to second row first column, okay, right? So which is 5x plus 4y, okay, and then plus 3 sin t, and then plus, and then 2. There is a 2, plus is there. So plus 2. So writing this way of things is called as what? Linear system. So what did I do in this question? I converted matrix to linear system. What I did? I converted matrix to linear system. So let me go back here. I converted linear system to matrix. Okay. I converted linear system to matrix. I converted linear system to matrix. But now what did I do? I converted matrix to linear system. I converted matrix to linear system. Clear everybody? So now there are two sets. Total I said 5 things you need to remember in part 10 of this video. What are they? The first one is linear system of equation to matrices. The second thing is what? Matrices to linear system of equations. Clear all of you? Right. Now the next thing we are going for what? We are going to the third part. What did I say third part? Write the given differential equation as a first order system using matrix notation. What we are going to do? Using matrix notation. Keep in your mind. Okay. Right. So we are going to start this one. Let me read the question. Write the given differential equation as a first order system using matrix notation. Let me underline what are the important points. You have to write the given differential equation as a first order system using matrix notation. What is first order? What is first order? It means first order means dy by dx. That is your first derivative. That is called first order. So for that, I'm going to give some important formula here, or you can say rules, or you can say some substitutions. You can say like that. What is that? The first thing which I'm going to give is write y is equal to x1. This is the only thing you have to remember. Remaining things automatically it will come from steps. Okay. What is that? So let me start the things which I'm going to do it now. So first you take a derivative. Y dash is equal to x1 dash. This is the first derivative. I'm just calling as simply say x2. I'm just saying say x2. Why? My job is to reduce the derivative. So I keep reducing the things. Then I'm going for y double dash. When I go for y double dash, and here you will get what? X2 dash, and here you will get what? X1 double dash. Don't look at the things in the middle. Keep in your mind. Then after that, I'm going for y triple dash, which is equal to x1 triple dash, which is equal to x2 dash, which is equal to, I'm just going to say this is x3, and this is going to become x3 dash. Okay. It's a very simple. Don't get confused. Don't get confused. Once again, let me write everything again. Don't worry. Once again, I will write everything. Get it. So only formula you have to remember is y is equal to x1. Take the derivative. Derivative means y dash, which is x1 dash. For simplicity, I'm calling as x2. Right? And the next is, again, I'm taking derivative, which is y double dash. So which is x1 dash, which is equal to, this is x2 single dash. So for sake of simplicity, I'm calling as x3. I'm going for the next derivative, y triple dash, which is x1 double dash, which is equal to x2 double dash. For sake of simplicity, I'm going to call this as x4 say. I'm going to call this as x3 dash. Okay. And then I'm going to call it as x4, right? Keep in your mind. Very simple. So I'm going to give you some more rules here as a standard rule. What is the rule? Whenever a question is given, keep in your mind. Whenever a question is given, keep in your mind. Look at the higher order derivative. Look at the higher order derivative. Look at the higher order derivative. Look at the higher order derivative in the question. What is the higher order derivative here? Which is y double dash. So let me write the equation here. 4y double dash plus 4y is equal to t cos t. So try to write the equation always y double dash is equal to minus 4y plus t cosine t. What is this, teacher? Yes. Keep left hand side y double dash. Bring everything to the right hand side. Bring everything to the right hand side. Okay. Then afterwards, what should I do, teacher? Mainly you have to convert, or you have to reduce to first order. Right. What is your y double dash from this? First order. This is your first order. Can you see that? First order. Okay, I made a mistake. X1 double dash, this one. This is a first order. X2 dash. Can you do this? Okay. Still it is not clear. Again, I will do once again. Don't worry. Remember the formula y equals x1. Take the derivative y dash, which is x1 dash. Just call it as, for simplicity, x2. Then double dash, y double dash. You can also call it as x2 dash. And this will be what? X1 double dash. So call it as this x3. Then go for y triple dash. And this will be x1 triple dash. Or you can say that, I think here also I made a mistakes. So let me erase this one again. I will write it. I think already you are confusing. I am also making you to confuse. Just a minute. I will write a clear way. Sometimes, nobody is in front of me, so I don't know what I'm doing. Right. So y equals x1. So take the first derivative, y dash, which is equal to x1 dash. Clear, everybody? Clear or not? Yes. Which is equal to what? X2. Next, y double dash, which is equal to what? X1 double dash, which is equal to what? X2. Okay, I'm sorry, again making mistakes. Y double dash is equal to, forget about this. This is equal to x2 dash. Okay, I'll write directly to the last step. Okay, x2 dash. Right, now next I will write y triple dash, which is equal to what? Y triple dash, which is equal to x2 double dash. And I'm calling this as x3, which is equal to x3 dash. Clear? Clear or not clear? Yes, clear. So in this place you will be getting what? X1 double dash you will get. And in this place you will get what? x1 triple dash you will get. So please concentrate on the double dash. Okay, right. So again, shall I do it? So once again I'll do, because still your looking is different manner, right? So again I'll tell you y double dash is equal to x2 dash, which I'm going to call x3 simplicity. And then y triple dash is equal to, I'm just going to write as x3 dash. Is it okay? Right? So just keep it. Right. Now just write it y double dash in terms of first order derivative. So what is y double dash in terms of first order derivative? First order derivative y double dash is what? x2 dash, which is equal to minus 4 times, keep in your mind, in the right hand side, keep in your mind, you should not get any derivative. Should not get any derivative expression or equation or any derivative. That means what? That means what? Here I put x2 dash, right? Here you should not put anything related to dash. All the things should be free from dash. Okay. So what can I write for y without dash? Y is nothing but what? x1. This is the extra fitting, right as it is. Any question? Any question? No. Right. So whenever you are getting some x2 dash, call that equation as number 2. Call this equation as what? Number 2. So what will be your first equation, teacher? Look here. We want to write in a matrix model. When you are writing in the matrix model, look here. When you have dx by dt, you have dy by dt, right? At the same time, when you have x1 dash, you should have x2 dash, right? Then only we can write in the matrix model. So same thing. Now you got an equation x2 dash. So you need something in x1 dash. We have an equation x1 dash. Can you see here? x1 dash. So x1 dash is equal to what? x2. What is the meaning of this? This is equal to, I'm going to write it as 0x1 plus x2. 1x2, I'm going to write it. So what I'm going to write, x1 dash is equal to 0x1 plus 1x2. I'm going to write like this. This is going to become your first equation. Now, equation is ready. I'm going to write in a matrix model because they said, please write it in matrix notation. So I'm going to write in matrix notation. How? In the left hand side, I write x1 dash and I write x2 dash, which is equal to matrix model. And the equation variables are x1 and x2, plus you have extra fittings. This is called what? Extra fittings. Okay, right. So what will be your first equation? Look at the first equation always, which is 0 here, right? And 1 here. Look at the second equation. Here minus 4 here, right? And look at your x2 here. There is no x2. So you're going to write 0. And your extra fitting in the first equation, there is nothing. And the second equation, it will be t cosine t. Clear? Clear or not clear? It's very clear. Okay. No problem. We will do one more problem also. You will get the whole idea. Right. Let me come to the same question again. Same idea. Right. So what we need to do, what are the things you need to remember in the side? Y is equal to x1, the first part. Y dash is equal to what? x1 dash, you just call it as x2. What is y double dash? Just you call it as this x2 dash, which is equal to x3. That's it. Is it easy for you now? Yes. Now, what did I say? Always you write the higher order derivative in the left hand side, y double dash. Remaining all you go that side. When you are going this side, keep writing orderly. What do you mean by orderly, teacher? It means y, y dash, then constant. Y, y dash, then constant. Right like that. So what is the first one? This 2y is going that side. So it will be plus 2y. This 2y dash going that side. It will be minus 2y dash. After that, already the extra fitting is on the right hand side. So which is 3t minus 9. Clear? So you write the equation y double dash. Now you want to write y double dash as a first order. One single dash. What is y double dash as a first order? What is y double dash as a first order? We are going to write y double dash as a first order. So how we are going to write y dash as a first order? Look at here. Y double dash here is the first order. This is the first order. Okay, everybody? Right. So this the first order is x2 dash. Okay, 2 times, and I told you this side, completely this side, you should not get any derivative. You should not get any derivative. Keep in your mind, should not get any derivative. What's the meaning of derivative? Y dash, x1 dash, x2 dash, no dash. That is called no derivative. You should not get any derivative. Right? What is the value of y? Which is x1 minus 2 times, what's the value of y1 dash? X2 plus this is extra fitting 3t minus 9. So we got an equation in x2 dash. Now I need an equation in x1 dash. The same manner I'm going to take this equation is what? X1 dash. So x1 dash is equal to x2, but I'm going to write this as 0x1 plus x2. Is there any extra fitting? Is there? No extra fitting. So I'm writing 0. Now I'm going to write in the matrix equation. So write as a matrix equation. This is your equation 1, right? This is your equation 1 and this is your equation number 2, right? This is your equation number 2. Let me write in a proper way. This is your equation number 2. Yes. Now, equation number 1 we are writing as x1 dash and this is x2 dash equal to, there is a matrix and there is a column matrix x1, x2 and then plus extra fitting. Okay, right. Let's start. Equation 1 which is 0 and this is 1. Equation 2, 2 is here and minus 2 is here, right? And the extra fitting in the first equation is 0 and the second equation is 3t minus 9. Okay, it is clear? Clear or not clear? Very, very clear. So easy this equation. Very, very easy. Okay, right. So in this way, we are going to write the given system of equations, right? This one as a first order system of equations. That's what we are going to do it, right? So let us do one more question in this with the help of what? Third order derivative, right? Okay, let me go third order. Yes, here is there, right? So write the third order differential equation, right? Third order differential equation as a first order system. Same formula, I'm going to use it. Y equals x1. Y dash is equal to what? X1 dash which is equal to x2. Y double dash is equal to x2 dash which is equal to x3. And y triple dash is equal to x3 dash which is equal to x4. Right? Yes. So let us go to the solution. Right? Yes. Y triple dash plus 2y double dash minus y dash minus 2y is equal to 3 e power minus t. What did I say? I said higher order derivative, keep it on the left hand side. Higher order derivative, keep it on the left side always. Left side always. Keep it on left side always. Well, look here. Here what did I do? I kept the second order derivative here, right? It is not written. I changed first order. Second order derivative is a higher order derivative, right? Yes, look here. Second order derivative, I kept it on the left hand side, remaining all the other side. Similarly here, I am going to keep the third order on the left hand side, remaining all I am taking to other side. Why I am taking to other side? Keep in your mind, you should write orderly. What do you mean by orderly? Y, y dash, y double dash, like that. Okay, right. Let me start first. So when I go with this, I will get first is plus 2y. This goes to the other side. Clear? Next, this goes to the other side plus y dash. This goes to the other side minus 2y double dash. So this is equal to, what did I say? I said this side completely you should not have any derivative. Keep in your mind, you should not have any derivative. Should not have any derivative. Okay, right. So how I'm going to write it? Listen. 2 times, what is your y? Your y is your x1 plus what is your y dash? X2. Teacher, can I write this x1 dash? No, it is derivative. Keep in your mind. What did I say? You should not have any derivative. Keep in your mind. Okay, right. Minus 2y double dash. What you should take? X3. Okay, right. So when you look this equation, right, I'm sorry, I didn't write for y triple dash. Y triple dash is what? First order derivative. So here is first order. This must be first order. Okay, yeah, right. This must be first order. Right. This side, no. Because the question is what? As a first order. Right. So now if you look at the equation, it is x3 dash. Before, in the previous question, what did I get? In the previous question, I got x2 dash. And before one question, I got x2 dash. So I got x2 dash. I make a matrix x1 dash, x2 dash. Now I got x3 dash. So it should be what? 3 by 3 matrix. Right? Okay. So I need what? x1 dash, one equation. I need x2 dash, one equation. We already have here, right? x1 dash, x2 dash. Let me take this one. x1 dash is equal to x2. I will take this equation. x1 dash is equal to x2. Then I will take the next equation. x2 dash is equal to x3. So I will take the next equation. x2 dash is equal to x3. But how I am going to write? Just see the fantasy over here. So there is no x1. So 0 x1. There is x2, 1 x2. And there is no x3. It is 0 x3. And this equals, there is no x1 and there is no x2 and there is a x3 which is 1 x3 plus 0 fitting plus 0 fitting. So let me call this as equation number 1, right? And let me call this as equation number 2. And let me call this as equation number 3. I will call this as equation number 3. Okay. So equation 1, equation 2, equation 3. Now what is my job? My job is to write in a matrix model, right? Let's start. Nice. So we have x1 dash, x2 dash, x3 dash of t, you can say. This equals, we have a 3 by 3 matrix. Start from here. 0, 1, 0, 0, 0, 1. And then here you start. 2, 1, minus 1. 2, 1, minus 1. 0, 1, 0. 0, 0, 1, right? After that, you have 3 3 variables with a column matrix. And then plus your extra fitting. Over here, it is 0. Over here, it is 0. Over here, there is, yes, there is something. Plus 3e power minus t. Plus 3e power minus t. So, this is plus 3e power minus t. So this is the way of writing the given system as a first order and the representation is a matrix notation. Clear all of you? Very easy. Just electrical engineering students, they just grab it quickly. Tuck, 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 they will finish it. It's so nice, right? We are going to the next topic. The next topic is what? Verify that the vector x is a solution of a given linear system. What do you mean? You're going to verify x is a solution, right? What do you mean by this? Suppose I give an equation, x plus y is equal to 3, right? I say that verify x is equal to 1, y is equal to 2 is a solution. If I ask you, what you will do? You will put x equals 1 and y equals 2. How much you are getting? 3. So if the left is equal to right, then it is going to be what? Solution. Suppose I say check x is equal to 1 and y is equal to 1 is a solution. What you do? Put x is equal to 1 and y is equal to 1. 1 plus 1 is equal to what? 2. Is the 2 is equal to 3? No. So what you will write? It's not a solution. This is what? Same thing, simple. Here it's a differential equation. That's it. Such a nice thing, right? So we have a differential equation and we have a solution over here, right? Yes. And it is with two variables. Okay, right. Let me take the solution. What is the solution? The solution is x equals matrix 1, 2 and e power 5t minus 5t. Matrix 1, 2, e power minus 5t. Okay, right. So we are going to make what? As a solution. So let me write this as x equals, x is a column matrix, okay, and it's a capital X. You know this very well. Capital X is nothing but what? We'll take x and y because the variables are x and y. And this will be 1 times this e power minus 5t and 2 times this 2 power e power minus 5t. Okay, right. So it means what? Your x is equal to what? E power minus 5t and y is equal to what? 2 e power minus 5t. Something like x is equal to 1, y is equal to 1. You need to check this is the solution for these two equations. Two equations together we call it as system of equations. Okay, we can put x here, we can put y here. Where is your dx by dt? We can put x here, we can put y here. Where is your dy by dt? So we need to find, right? Dx by dt and dy by dt. What is dx by dt? E power minus 5t times minus 5. What is this one? 2 e power minus 5t. E power minus 5t is what? Minus 5. So which is going to become what? Dx by dt is equal to minus 5 times e power minus 5t. And dy by dt is equal to, dy by dt is equal to minus 10 times e power minus 5t. Is it okay? Right? Yes. So this is your dx by dt and this is your dy by dt. Let me take the first equation. Okay. So I'm going to check with the first equation, right? So let us take equation 1. Let us take equation 1. Okay. What is equation 1? Dx by dt, right, is equal to 3x minus 4y, right? So the left hand side, this I'll call it as left hand side. This I call it as right hand side. Left hand side we already calculated just now. Dx by dt. What is that? Minus 5 e power minus 5t. We got it. Now right hand side I need to check, right? Right hand side I need to check. Yes. What is right hand side? 3x minus 4y. So 3 times what is your x? Your x is here. E power minus 5t. E power minus 5t. Minus 4 times what is your y? Your y is 2 times e power minus 5t. So 3 e power minus 5t minus 4 times 8. 8 e power minus 5t. Okay. So this is equal to 3 minus 8 is what? Minus 5 times e power minus 5t. So this is going to become our right hand side. Okay. Check left hand side is equal to right hand side. Check left hand side is equal to right hand side. Of course, yes. But this is only for the first equation, right? Now we have to check what? Equation number 2. So we are going to check equation number 2, right? What is your equation number 2? This is your equation number 2. dy by dt, right? So dy by dt equals, dy by dt equals, dy by dt equals, right, which is equal to 4x minus 7y. So what is your left hand side? Your left hand side is dy by dt. Just now we calculated. How much dy by dt? Which is equal to minus 10. So minus 10 e power minus 5t. So let us call this as left hand side. Let me start right hand side. So right hand side is what? 4x minus 7y, which is equal to 4 times. What is your x? Your x is e power minus 5t. So x is e power minus 5t minus 7 times. What is your y? Your y is 2 e power minus 5t. So 2 e power minus 5t. So this equals 4 times e power minus 5t minus 7 into 4 is 14 e power minus 5t. And this is 4, this is negative 14. 4 minus negative 14 is negative 10 e power minus 5t. So this is going to become your right hand side. Check with your left hand side. Wow, fantastic, right? So such a nice thing, right? So finally, what you can conclude from this, right? So we can say that x equals e power minus 5t and y equals, I think, 2 e power minus 5t. Yes, x is this, y is this. Yes, is a solution for the system of equations. Is a solution for what? For the system of equations. Clear, everybody? Right? Yes. So this is how to verify the vector x is a solution for the given linear system, or you can say homogeneous linear system also, you can say, no problem, right? So the next question is verify that the vector x is a solution of homogeneous linear system. Same set of equation, but the solution is different. Okay, right? So what is the solution? Capital X, I told you, you have to take x and y, which is equal to, right, which is equal to what? 5 cosine t and 3 cosine t minus sine t is a column matrix and with e power t. Okay. So with this e power t, right? So e power t, right? So this can be written as 5 cosine t e power t. Okay. And this can be written as e power t is common, 3 cosine t minus sine t, you can write it, close the matrix. So this is your xy. So what is your x is equal to? Your x is equal to 5 cosine t e power t. And what is your y equals? E power t times 3 times cosine t minus sine t. Is it okay, everybody? Right. So this is your y. Right. Now what we need to do? We need to check this is a solution for this equation as well as this equation. So we need dx by dt. We need dy by dt. So let me start. Dx divided by dt, which is equal to what? Here is also t is there. Here is also t is there. So what we need to use? You use product rule. Right. So 5 cosine t, keep it. Derivative of e power t is e power t and then plus, okay. Keep e power t, derivative of 5 cosine t is minus 5 sine t. Okay. Let me simplify this, which is equal to, right, e power t, I'll take it as a common, right, amil mushtarak. Okay. So here it is 5 cosine t and then here minus 5 sine t. But still I can take 5 also common, right? So this equals 5 e power t, I can take it as common, cosine t minus sine t. This is my what? Dx by dt. So let us keep it ready. Okay. Now let me go for dy by dt. Okay. So dy by dt is equal to, right, here also product u v. Okay. Okay. Sorry. So here also you have a product u and v. Okay. Right. So product, this is u. I'm sorry. Yes. So this is u and this is v, right? Keeping u e power t, the derivative of 3 cosine t, how much? Which is going to become what? Come on, take the derivative, right? So minus 3 sine t and then minus cosine t, because derivative of sine t is what? Cosine t. Plus, keep this 3 cosine t minus sine t and then derivative of e power t is what? E power t. Now, I'm going to take e power t as common. When I take e power t as common, minus 3 sine t, okay, minus cosine t. Here also e power t is common. So, I'll get 3 cosine t and then minus sine t. Overall, I'm taking e power t as common. So, e power t times, here is minus 3 sine t, here is minus sine t. So, it's going to become what? Minus 4 sine t, right? Here is minus cosine t, here is 3 cosine t, which is going to become what? 2 cosine t, right? So this is my dy by dt, okay? So this is my what? Dy by dt, okay? So let me have a box and keep it ready, dy by dt. So dx by dt is ready, dy by dt is ready. I need to take the first equation, okay? Let me check how many pages are there. I can go a little bit away, yes. There are so many pages are there. So let me take the first equation. The first equation is, right, dx by dt is equal to minus 2x plus 5y, right? Yes, what is my x? X is equal to 5 cosine t e power t. What is my y? Which is e power t times 3 cosine t minus sine t. I have a question. So let me check whether 5 cosine t e power t 3 cosine t minus sine t. Okay. Yes, let's start the left hand side. What is my left hand side? My left hand side is dx by dt. So we already got dx by dt just now. This is my answer. What is that? 5 e power t bracket open, okay, and then cos t minus sine t. So this is cos t minus sine t. So dx by dt is ready. Let me go for right hand side. What is my right hand side? My right hand side is minus 2x plus 5y, which is equal to minus 2 times, what is my x? 5 cosine t e power t, okay, right, and then plus 5 times my y, which is e power t 3 cosine t minus sine t, okay, right. So let me take common e power t as common. This e power t gone, this e power t gone. So here it is minus 10 cosine t, because 2 times 5 is my negative 10, and then here 5 times 3, this 5 times 3 is 15 cosine t, and then 5 times 1 is negative 5 times sine t. Okay, so this equals e power t times negative 10 and then 15, which is going to become what? 5 cosine t, right? And this is 5 sine t. So this is 5 sine t. So this is equal to, right, e power t times, and I can take amal mushtarak as 5 as out. So I'll get cosine t minus sine t. Let me check my answer for dx by dt is the same or not. 5 e power t 5. Oh, nice. Cosine t minus sine t. So this is equal. Not only one equations, you have to check two equations. Keep in your mind. Okay, right. So let's go to the next equation. The second equation is, I'll write this is equation 1. This is equation 1. Okay, right. So take this one, right. Equation 1, this one. Let me go for equation 2. The second equation I'm going. Okay, equation 2. Let me go for equation 2. Okay, right. What is your equation 2? dy by dt is equal to negative 2x plus 4y. So my left hand side is what? dy by dt. Okay, right. So dy by dt equals, just now we calculated, which is a lengthy one, e power t, right, minus 4, e power t minus 4 sine t, e power t minus 4 sine t plus 2 cosine t, plus 2 cosine t is my dy by dt. So this is your first equation, which is, let us keep it. Okay, now we go for right hand side. What is my right hand side? My right hand side is minus 2x plus 4y, right? So which is equal to minus 2x. What is your x? We have it 5 cosine t e power t. This is my x. Plus 4. What is my y? Y I have 3 cosine t minus sine t, right? And the common is what? E power t. So altogether I'm going to take e power t is common. If I take it minus 10 cosine t, I will get, here I will get 4 into 3 is 12 cosine t, and here I will get is minus 4 sine t, right? So this equals e power t bracket open minus 10, right? And then plus 12, minus 10 and then plus 12, which is going to become what? 2 cosine t minus 4 sine t is my right hand side answer, and I will check it out whether it is same or not. E power t neg 2 cosine t, yes, 2 cosine t is there, and minus 4 sine t. Wow, it's going to become what? Same answer, right? So both the equations are satisfied. So finally what you're going to say? You're going to say x equals 5 cosine t e power t and y equals e power t times 3 cosine t minus sine t is the solution of the system of equations. Clear, everybody? Clear? Wow, lovely question. So lovely, so easy, and nothing is there, just we are taking the derivative and we are using the idea of what? Calculus 1, that's it. Now we have come to the last section. Find the general solution of the given system of equation. Very, very important. So keep in your mind the general solution of the given system of equation. For this, you need to follow few steps. What are they? Very easy steps which you already studied. So let me go to the solutions and I will give you the steps. Okay. Step number 1, find eigenvalues. What is the step number 1? Find eigenvalues. And step number 2 is find eigenvectors. Already we studied, and if you have not studied, please go back to the videos and get ready with that, then come back to this one, right? Next, number 3 is we are going to write the general solution. Number 3, you are going to write the general solution. How you are going to write the general solution? Let me write. It's a matrix model. After that, equations. X of t, y of t equals, okay, C1, okay, and then eigenvector here. It's a column vector. I told you, eigenvector is a non-zero column vector, okay, and e power lambda 1t. This lambda 1 is an eigenvalue, plus C2, right, and open a column vector, here vector, not matrix, eigenvector, okay, and e power lambda 2t. So this one you have to memorize. There is no other option. So this is the formula to find the general solution. So what is lambda 1? Lambda 1 is the eigenvalue. So what is lambda 1 and lambda 2? sorry, 1 minute, right? So lambda 1 and lambda 2 are eigenvalues. Lambda 1 and lambda 2 are what? Eigenvalues. Okay, right. So let me go to the question and then we'll start. So this is a differential equation, right? This differential equation we can write in a matrix model. How? We can write dx divided by dt and dy divided by dt. Okay, right. This is equal to what? 1, 2, 4, 3. Why? 1, 2, 4, 3. And then the column matrix is xy. So from this, what is your matrix A? 1, 2, 4, 3 is your matrix A. For this matrix, you are going to find the eigenvalues and eigenvectors, right? Okay, let me start. Okay, step number 1. So my matrix A is 1, 2, 4, 3. It's a 2 by 2 matrix, right? So step number 1, I'm going to find eigenvalues. Step number 1 is what? Find eigenvalues. So I told you the eigenvalues, how to find out. That is, we are going to find what? Characteristic equation. How you find the characteristic equation? Lambda square minus beta 1 lambda plus beta 2 is equal to 0. What is beta 1? Sum of leading diagonal elements. What is that? Sum of leading diagonal elements, right? And what is beta 2? Beta 2 is equal to determinant of A. Right. So let us calculate beta 1. Beta 1 is equal to sum of the leading diagonal elements. This is called leading. How you can call leading diagonal? First element in the first row. First element in the first row. Okay. And second element in the second row. Second element in the second row. Right. And second element in the second row. It follows like that. Third element in the third row. So 1 plus 3, which is equal to 4. So beta 1 is equal to 4, right? And beta 2 is equal to determinant of A. I taught you in the class how to find determinant of A using calculator. But it's a simple matrix. Let me find out. 1 times 3 minus 4 times 2. 1 times 3 minus 4 times 2. But for 3 by 3, 100% use the calculator. Also, you can check your answer whether it is correct or not. So 3 minus 8 is going to become what? Which is minus 5. Which is beta 2 is equal to what? Minus 5. So we got beta 1, we got beta 2. Let me go to the characteristic equation, which is lambda square minus beta 1 lambda plus beta 2 equal to 0. Teacher, I don't like beta 1, beta 2. Can I write AB? Can I write A1, B1? Can I write A2, B2? Anything you can use because they are constants. Nothing worry about that. So this is lambda square minus beta 1 is 4 lambda plus beta 3 is minus 5 equal to 0. Now what you need to do? You need to go to the calculator, use mode 5 and then 3. Right. So when you use mode 5 and then 3, you will get lambda 1 is equal to, let me use the calculator, 1 minute. I know the answers, but still let me go with the calculator. Sometimes it can be wrong. Yes, mode 5 and then 3. Right. So it's going to become 1 and then, 1 and then minus 4 and then minus 5, which is going to become 5 and minus 1. Don't change the order, keep the same order. And lambda 2 is equal to minus 1. So lambda 1 is equal to 5 and lambda 2 is equal to minus 1, right? Yes. Now this is called what? This is called eigenvalues. This is called what? Eigenvalues. Now we are going to find what? Eigenvectors, right? Now step number 2, we are going for what? Eigenvectors. Step number 2 is what? To find eigenvectors. Okay. To find eigenvectors. Yes. How to find eigenvectors? What is the formula? Matrix A minus matrix A minus lambda I times X matrix is equal to what? 0. Right, I told you in the class itself, the matrix got a change over in the diagonal. So the matrix is 1, 2, 4, 3. Am I right? Yes, right. So now changes happens in the diagonal. 1 minus, you're going to get lambda. And 3 minus, you're going to get what? Lambda. So these are the changes. Remaining all going to become same, which is 2 and 4. And I told you in the class for 2 by 2 matrix, it's a column vector x1, x2 is equal to 0, 0. So you're going to call this as equation number 1. Okay, right. Yes. So now we have two things. What are they? Case 1, we are going to put the first lambda value 5. And case 2, we are going to put the second value what? Lambda is equal to minus 1. So let me go in the same page itself. It is easy for me to follow this. So I'm going to call this as equation 1. Already called. Okay. Put lambda is equal to, what is the value? 5. Put lambda is equal to 5 in equation 1. If I put lambda is equal to 5, what I will get? Okay, open a matrix. 1 minus 5, 2, 4 and 3 minus 5, right? And times x1, x2 is equal to 0, 0. So this is going to become what? 1 minus 5 is minus 4, right? And then 2 and then 4 and then minus 2 times x1 x2 equal to 0. I told you already, for 2 by 2 matrix, most of the time you will get what? Identical equations. So no need to take the second equation. No need to go for cross multiplication method like 3 by 3 matrix. But you can go directly with the first equation. So what is your first equation? First row, first column, which is negative 4x1 plus 2x2 is equal to what? 0. Right. I told you in the class all the time you just write x1 equals. So minus 4x1 equals negative 2x2. Okay. Minus 4x1 is equal to what? Negative 2x2. So now what happens? I'm going to divide by minus 4. I'm going to divide by minus 4. Okay, so when I divide by minus 4, it gets cancels, right? Minus 4 and minus 2 gets cancelled with this, and I'm going to get 2 here. So let me write here x1 equals plus x2 divided by 2. Okay, right. What did I say in the class? Try to give a non-zero vector. Try to avoid fractional values, right? So what I'm going to do, I'm going to choose x2 is equal to 2. So I'm going to choose x2 is equal to 2. If I choose x2 is equal to 2, what I will get? 2 by 2 is equal to what? 1. So choosing x2 is equal to 2, x1 equals 2 by 2, which is equal to 1. So finally, your capital X1 eigenvector is equal to x1 is 1 and x2 is what? 2. So it is 1 and 2. Okay, right. So let me divide it here line. Okay, so I'll divide it by line. I'll divide it like this. Let me go for the next one. Right. Now what I'm going to do it? I'm going to do case 2. What is case 2? Put lambda is equal to case 2. Right. Put lambda is equal to case 2. Put lambda is equal to, what is the value lambda? I think minus 1 if I'm not mistaken. Yes. Lambda is equal to minus 1. In equation 1. So this is your equation 1. Okay. So 1 minus of minus plus 1, right? And 2 and then 4. 3 minus of minus 1 is 4. So you're going to get this one. x1, x2 is equal to 0, 0, right? So I'll get 1 plus 1 is 2, 2, 4 and then 4. We are getting identical equation, see, right? So this equals 0, 0. Here also identical equation, see, 4 and minus 2, same number with minus and plus, okay, right? So we are going to get what? First row, first column. So it will be 2x1 plus 2x2 is equal to 0. So I'm going to write 2x1 is equal to, I'm going to write what? 2x1 is equal to negative 2x2, right? So I divide by 2, I divide by 2. So x1 is equal to negative x2, right? x1 is equal to what? Negative x2. So what values you're going to choose? Right, choose easy value. x2 is equal to 1. If I choose x2 is equal to 1, x1 equals what? Minus 1. So which is going to become what? x1 is equal to minus 1. Okay, don't confuse, it is 1. Right. So what will be my column vector x2? x1 is minus 1 and x2 is equal to what? 1. Sorry, x1 is equal to 1. Sorry, x2 is equal to, x1 is equal to minus 1 and x2 is equal to, no, wait. Choose x2 is equal to 1. Sorry, choose x2 is equal to 1 and x1 is minus 1. Okay, teacher, can I choose x2 is equal to minus 1? Yes, you can choose x2 is equal to minus 1 also. Can I choose any other value? Yes, you can choose any other value. Okay, right. So it's going to become what? So like, can I choose 1, teacher? Yes, you can choose 1. Already we have chosen 1. x2 is equal to 1. So when I choose x2 is equal to 1, x1 is equal to what? Minus 1, right? Yes. So in this way, we are going to get the answer, which is 1 and minus 1. Let me explain again. This is the equation all the time. You write x1 is equal to minus x2. choose some values for x2. Choose some values for what? X2. For example, I choose x2 is equal to 1. If I choose x2 is equal to 1, put here. So minus 1. x1 is minus 1. So first is x1 minus 1. Second is x2 is plus 1. So this is your column vector, which is x2 second eigenvector. So we got x1 eigenvector and we got x2 eigenvector, right? Now we are going to write the solution, which is step number 3. So what is step number 3? Step number 3 is you are going to write the general solution. So what is the formula for general solution? I gave you in the first steps. What is that? X of t you write as a matrix model, y of t, right, is equal to C1 times eigenvector, first eigenvector, okay, and e to the power of lambda 1t plus C2 times eigenvector, which is the second eigenvector, first eigenvector, okay, e to the power of lambda 2t, right. So this equals x of t and y of t, right, which is a matrix model. C1 times first eigenvector is 1 and 2. So which is 1, which is 2, e power, what is my lambda 1? My lambda 1 is 5, okay, plus C2, right, again a column vector x2, which is minus 1 and 1, minus 1, 1, e to the power of my lambda 2t, sorry, my lambda 2t is, lambda 2 is minus 1, minus 1t, sorry, minus 1t, okay, right. So now I got this one. You need to write as a solution, right, not in a matrix model. So what I'm going to do, first row, first column, like that I'm going to go. So right, so x of t is equal to, look here, 1 c1 e power 5t, go like this. So c1 e power 5t and then go like this. So minus c2 e power minus t, right, and x2 equals, or I choose x1 is minus 1, I choose x2 is equal to, there is a mistake or not, 2x1, so I get an equation 2x1 plus 2x2, so 1 plus 1, it's going to become 2, right. So I take lambda is equal to what? Lambda is equal to, let me check again, lambda is equal to minus 1. So if I take minus 1, what happens? Where is the matrix? Here. So lambda is plus 1 or minus 1, lambda is minus 1. So if I take lambda is minus 1, minus of minus plus, so it's going to become 2, 2, 4 and then 4, right. So lambda is equal to minus 1. So you'll get here also lambda is equal to minus 1. So 3 minus of minus, which is plus, okay, right. So it is 4. So which is going to become x1, x2, 0. So 2x1 plus 2x2, because I feel something wrong, that's why I'm just checking. So 2x1 is equal to negative 2x2, it's going that side, right, and then I divide by 2 and then divide by 2. So I get x1 equals minus 2 gets cancels, so I get negative x2. So I choose x2 is equal to 1, okay, if I choose x2 is equal to 1, x1 is minus 1, so I get minus 1, 1, correct, yes. Now we are going to write the solution, right, and then y of t is equal to, right, go down, right, from this side. So which is 2 c1 e power 5t and go from here and from here, and then plus c2 e power minus t, okay, right. So this is going to become your first the solution of this differential equations, okay, right. So I hope there is no mistake. 1 c1 e power 5t plus c2, take on this one, okay, right. So this is going to be your final answer, x of t and y of t, okay, right. So this is the general solution of the differential system of differential equations, right, okay, right. Now I have given some examples, you can see that, so you can practice, because all are same model. Find the general solution for this equation, and sometimes they will give you as this model. So if they give this equation like this, which is also same like this, how? Because I told you this x dash is nothing but what? X of t, that is derivative x dash. So this is dx by dt and this is dy by dt as a matrix, and this will be 10 minus 5, 8 minus 12, and x is a column vector, I said xy. So it means what is your equation? Dx by dt equals 10x minus 5y, and dy by dt is equal to what? 8x minus 12y. So which is same as this one. So you can also try this equation, which is also same. This is also same. So 4 equations, 4 questions I gave you. Please try. Not only 4, one more from the examples. I told you examples are very important. So please try these questions also, right? Yes. So in this way, module 3 is going to end in this section, right? This video we are going to finish your module 3, right? So what we are going to do, so in this way we are finishing module 3 of the course differential equations, right? Module 3 of the differential equation course. Alhamdulillah, with this video we have completed module 3 and with it the entire differential equation course MA203. I sincerely thank each and every one of you for your continued support, active participation and enthusiasm throughout this journey. It has been a great pleasure guiding you through these topics step by step, and I truly hope these lessons have made a real difference in your understanding and confidence with differential equations. What else I can say? Remember, mathematics is not something to fear. I know most of you get fear. You don't like mathematics, but you want to become an engineer. So it's not something to fear. It's something to explore and enjoy. Math is a fun. That's why I keep my logo as solve, learn with Zahir math. It means what? You're going to solve the questions. You're going to learn with Zahir. Okay, right. So never hesitate to review, ask questions and keep practicing. This may be the last video of the course, but it's not goodbye forever. I will continue to post content for other math courses as well. Until then, I wish you all the very best for your final exams and your academic journey ahead. Stay motivated, stay focused, and most importantly, never give up on learning. Learning always should continue. Thank you once again. Assalamu alaikum wa rahmatullahi wa barakatuh. And final things, as usual, if you found this video helpful, don't forget to like, leave a comment and subscribe to the channel. Your support really motivates me to create more helpful content. Stay tuned for upcoming videos on other math courses, inshallah. Take care and see you in the next series. Bye-bye. All the best to everyone.